The cylinder head sits on top of the block, and between the cylinder head and the block is the head gasket, which forms a seal between this face and this face by sitting in the middle and being sandwiched between the two and then clamped down. The head gasket is the first gasket that we've come across on the engine. And what is a gasket? Well, a gasket sits between two surfaces and forms a seal between them. So when you've got a hard surface like cast iron on this block, there's actually little irregularities in that surface, little bumps and waves and troughs. The purpose of a gasket is to be a soft, more deformable substance that sits between those two hard surfaces and deforms or yields to fill these irregularities and create an airtight seal. The difference between a gasket and a seal is that a gasket is used between two static surfaces that don't move, whereas a seal is used where one of those surfaces does move, or in fact both of those surfaces moves. So a gasket. Now there's other gaskets on this engine. There's a gasket that's between the crankcase here and the sump. We've also got a gasket that sits around the water pump and in various other places. And those are made of different materials. So the head gasket is the most critical seal in the engine, really. It seals up the three different systems that circulate around inside the block and the head. So inside the engine we have three systems of fluids. We have the air and fuel mixture inside the combustion chamber, inside the cylinder here. We have the coolant, which runs through these passageways to keep everything cool, and we have the oil. And all three of those systems need to be kept separate, which is a major part, or in fact, the entire part of the job of the gasket. The head gasket is designed to be crushed. So it's installed here on the deck of the block, the head is placed on top, and then the bolts are torqued down to a specific tightness, and that crushes the gasket, creating the seal. And because the gasket is crushed, it's really only a single-use gasket. You would use this just once. Now there are specialist racing gaskets available that you can use multiple times, but on the whole, gasket, you only use it once. Once it's been crushed and the bolts torqued down, that's that, you need another one. This is the original gasket from when I disassembled the Miata. And this is a new gasket which was ordered, which is extremely low quality. So when you order gaskets, make sure you buy them from a reputable supplier, because although this one looked good in the feedback, it's actually completely unusable. And if you were scrimping on parts anywhere on a car, the head gasket is definitely not the place to do it. Anyway, regardless, we'll talk about this newer gasket because it's easier to see what's happening on it. The head gasket is designed to cope with extremely high temperatures, incredibly high pressures, and also different rates of expansion of the materials that it's in contact with. So down here we would have the engine block, which is made of cast iron, and on the top we have the cylinder head, which is made of aluminium. And the aluminium expands more than the cast iron, which creates a slipping across the surface of the gasket here. So that's a factor that has to be borne in mind when a gasket is designed. A head gasket is made from layers. So on the top and the bottom, we have a soft layer which deforms to fill the irregularities in the surfaces. And in the center, we have a stronger metal which gives some strength and resistance to too much crushing and sets the thickness of the gasket. Then around the cylinders, we have what's called the fire ring, which is a stronger metal which can take the heat of the combustion process. And around the passageways, we'll also often find some sort of sealing surface or a sealant, a soft sealant. This one's flaking off on this gasket. The thickness of a gasket is important. Now, if you've got a standard engine that you're buying a gasket for, then that will be specified by the manufacturer. But when an engine is modified or some alterations are made, then the thickness of a gasket becomes important, because the thickness of the gasket determines the volume of the combustion chamber. It also sets the piston clearance, so a thicker gasket will create a bigger clearance between the piston and the valves and the top of the combustion chamber. And so those factors mean that you can adjust the compression ratio using a head gasket to set that volume of the combustion chamber. When you're buying a head gasket, keep the old one and compare the two to make sure that you've got holes in the correct places. And don't scrimp and buy a cheap head gasket. Buy a reputable brand of head gasket, because this is really one place of a car where you don't want to be going back and replacing faulty parts. Manufacturers use the head gasket to fine-tune the flow of things around, so it's not surprising to find that there are passageways which appear in the block or the head which are blocked off or restricted by the head gasket. So if we look at this gasket here, for example, we can see we have two smaller holes which block off these two coolant passageways. We've also got coolant passageways which are blocked off completely on this gasket, which you can see. This is the original gasket from the car, so we can see the marks where the coolant hit this gasket. Installing a head gasket, fairly straightforward. There'll be locating pins on the engine block, and you just place the gasket down over those. Now there'll be a mark on there, usually for top or front, just to make sure that you've got the gasket aligned correctly on the block. Then you'll install the cylinder head and tighten those cylinder head bolts down. It's all in the preparation and the aftermath of replacing the head gasket that the labour goes. Blown head gasket is an iconic fault with an engine. So if you've got a blown head gasket, congratulations, you have an iconic fault. A blown head gasket means that we've got a breach in the gasket somewhere. So that could be a crack or a hole somewhere. And the problem with that is that what we have is, as we discussed, three systems inside the block. We have the fuel and air mixture and the exhaust gases in the combustion chamber. We have the oil in the oil passageways, and we have the coolant flowing through as well. And then around the engine, obviously, we have the atmosphere as well. Because there's three different systems and the atmosphere, a breach in the head gasket can cause all sorts of different symptoms, and it can also happen in different places. So, for example, there may be a breach between the combustion chamber and the oil passageway, or a breach that takes the coolant into the combustion chamber, or we could have a leak between two combustion chambers across the middle here, and all of those will have different symptoms and different consequences in terms of what happens in the engine. Let's take a quick look at a few of those. I'm not sure how many permutations of faults we've got here, but let's cover a few. So a breach between two cylinders is going to result in gases leaking from one cylinder into the next, and these will be at different positions in their four-stroke cycle. So the consequence of that will be a loss of compression, essentially. Poor running of the engine. A breach between an oil passageway and the combustion chamber will lead to combustion gases, exhaust gases, being forced into the oil system, and oil making its way into the combustion chamber. So we'll have oil being burned in the combustion chamber, which leads to blue gas in the exhaust and a buildup of carbon. And we'll also have exhaust gases in the oil system, which can lead to mayonnaise type deposits inside there and contamination of the oil. With a failure in the gasket between the coolant system and the combustion chamber, coolant can find its way into the cylinder, and then that will make its way out in the exhaust smoke as white steam. So you'll find white smoke coming out of the exhaust and a loss of coolant. The exhaust gases are forced into the coolant system, so that might present itself as bubbles in the coolant system or pressure inside there. And in a worst case scenario, in an extreme situation, coolant can be sucked into the cylinder, and as the piston tries to compress the mixture on the compression stroke, instead of air and fuel mixed into the cylinder, there's water, which is non-compressible, and the valves are closed, so as the piston comes up, it can't compress that mixture, and that can be a catastrophic failure for the engine because the connecting rod will bend or snap as it's basically forced up against a solid surface, unable to compress. So that's a condition called hydrolock, which is really the worst outcome from a failed head gasket.